So today we're looking at finding the volume of prisms. A prism comes in lots of different shapes, but the most basic one of all is a cube. All right? A cube is a prism. Now when we draw these, we tend to draw one, move it slightly right, slightly up, and draw it again, and then join up the sides. That gives us our three-dimensional picture of a prism. So a cube is the most simple one. Then we have also this one. That's called a rectangular prism or a cuboid. Now it becomes a cuboid because it's no longer squares. All right? Then we can have all sorts of other ones. We can have triangular prisms. All right? We can have a trapezoid or a trapezium prism. Okay? And then this one is a circular prism, but we call it a cylinder. All right? So all of those are prisms because if we take a knife and we cut through their length, we get that same shape that we put on our ends. So those ends get a special name. We're going to call it the facing side. So this is a facing side. This is a facing side. This is a facing side. It doesn't have to be facing you. It could be standing on the end. So the cylinder at the moment is rolling around, but it could be standing up like a tin. And it would still be this side that is the facing side. Because it helps us to find the volume. So we need to find the area of that facing side and then stretch it through the whole shape. And that stretch through the whole shape is called the depth. So for a volume, we get the area of the facing side times the depth. Now, what I would like you to do, because it will help you, is to find the area of the facing side before you multiply by the depth. Don't do it all in one step. If you do it all in one step, you're doing one thing. If you find the area of the facing side of the circle or the trapezoid here, then you are doing two things. You're finding the area of a tricky enough side to give you one tick, and you're finding the volume of that shape to give you two ticks. All right? So it is sensible to do it one thing at a time. So if we call this one 1, and we know that it is a square, all right? We know that it's all equal shapes, and that we know that this is 3 centimetres. All of the shapes. What's the easiest way to find the volume of this one? Not interesting. The volume will be the base or the height. We usually call it a length and it's cubed. Times the length times the length. What do we write that as? 3 dimensions. All right? So we're going to get 3 cubed, which equals 27 centimetres what? Cubed, right? We just did that one so it's a cube. We're going to have cubes. 3 dimensions means we have a power of 3. So in this one, we might have 5 metres by 2 metres by 10 metres as a swimming pool. We want to find out the volume of the swimming pool. So we will go volume equals base times height. That's the area of the facing side times the depth. Equals And the reason I'm not writing these out separately is because the shapes aren't tricky enough for us to get credit from it. 2 times 10. So we've got 10 times 10 is 100 metres cubed. All right? So in the next one, we've got a prism. Maybe it's a skateboard or bicycle ramp or something or other. It's fairly steep though. But let's say it's 3 metres by 5 metres by 4 metres. Right, now we need to break it down. So we want to find the area of the facing side first. So the AFS equals a half base times height. Equals a half of 3. That's not a 3, that's not a half. A half of 3 times 5, which equals 7.5 centimetres squared. Now we're going to find the volume, which is the AFS times the depth, which is 7.5 times 4 times 2 is 15 times 4 is 30 centimetres cubed. Except it was metres. Good, good. All right. So now we move on to the ones that are at curriculum level 5, which count. So these two are good examples of them. And the first one, this one here, so that was 2, this is 3, 4, and 5. So in 4, we're looking at the area of the facing side being a trapezoid. What's the formula for that? Who's got their formula sheet in front of them? Trapezium is good. Good. So even the recognition that that is the formula you are using, now if you get it right, you will get 1 tick out of the 3 you need. So our measurements we need, so we're going to have 10 and 6 and the height. We need that as well, is 3 centimetres, and the depth, which is going to be 8 centimetres. Right, so to find this one, we've got lots of measurements up there. They might put that slanty one on just to make sure you know it doesn't matter. All right, make sure that you are not choosing that, right, Tian? A half, 10 plus 6 times 3. A half of 10 plus 6 is 8 times 3, 24 centimetres squared. Right, the volume is the AFS times the depth, which equals 24 times 8, which is 32, 160, 192 centimetres cubed. All right, and then we get to the last one, which you've got the formula right there on your formula sheet. So if worst comes to worst, you use the formula off your formula sheet, but if you can remember to do it this way, you get those two ticks. So we want the area of the circle. So we're going to say the diameter of this concrete tube is 2 metres, and it's 5 metres long. Go with that. Right? So the area of a circle, we write down the formula first for the area of a circle is pi r squared. Okay? We've got r equals, what's r equal to? What's the radius of the circle? 1 metre. So we've got pi times 1 squared, which means pi, so 3.14 metres squared. So it's silly to write pi squared because that doesn't sound like a measurement. Then we want the volume, so it's the AFS times the depth. So 3.14 times 5 equals 15.577 meters cubed. And because we use pi in this one, we're going to say that that's accurate to 2dp, because that's where we rounded. All right, any questions? Awesome.